Okay, good morning, ladies and gentlemen. It's great to be here. Great to be in Plymouth today, and to see the sort of blend of activities that are going along in the tents just next door about small businesses and business opportunities versus what I gather has been a really good event here based around marine science. I have to say, I think I've probably got an awful lot more to learn from you than you have to learn from me around marine sciences and the oceans and things like that. But what I would like to try and do is give you an overview of the role that the Technology Strategy Board plays in the UK commercialisation and innovation landscape, try and make some links back to some of the things that you've been talking about, and the kind of tools that we have in place that can help to bring some of the ideas and the science that you've been working on into commercialisation and into creating economic wealth. I mean, just a bit of background about myself. I'm an engineer by background, 25 years working in the aerospace business. I joined the Technology Strategy Board about 5 years ago. It's a UK government organisation. I joined the organisation because I felt those links between science and the great things that were going on around universities around the world were not actually making their way into commercialisation and into business practice. The Technology Strategy Board has been set up as the UK government's innovation agency. Our role is principally to support or to promote UK economic growth through the support and stimulation of business-led innovation. But making those links from science into commercialisation is a huge part of what we're about. Our vision fundamentally is how can we help UK businesses bring new ideas and technologies faster to market. A little bit about us as an organisation. We work very closely with the research councils. I know Duncan Wingham spoke to you yesterday, particularly from the National Environmental Research Council perspective. But we are an innovation agency, about 180 people, predominantly recruited from business, responsible for investing around £400 million per year across a broad range of themes, a broad range of tools to support business. The majority of people in the organisation do actually come from business itself. What we're trying to do, in a generic sense, is help UK businesses, large businesses, strengthen their global competitive position, to try and encourage businesses to invest here in the UK. We're trying to identify supply chains, the SMEs, the mid-sized companies, so that we can grow them and build supply chains. And we try and identify the sort of small businesses that are coming either out of university spin-ups or from various ideas and grow them into the big businesses of tomorrow. In terms of the way we make decisions about the kind of projects that we support, it's not based around science, it's not based around excellence in science, it's based around 4 simple criteria. Is there a market? Can we create wealth out of that market? From our perspective, can the UK do it? Can it take advantage of that particular idea? Is the idea ready in a reasonable timeliness? We're not looking at 10-year, 15-year, 20-year timescales. We're looking at something where we can create economic wealth in a period of, say, 3 to 5, 7 years. And with the Technology Strategy Board, the intervention of UK government's funding, would it make a difference? So those are the kind of criteria that we're always looking at in terms of where we place our investments. Just to talk a little bit about the sort of areas that we see as our priority areas for investment. And this chart is probably the single most important chart in defining the priority framework that we as an organisation work on. And you won't see marine written on that chart, and you won't see oceans written on that chart, but you see lots of opportunities for businesses to create economic wealth out of marine, out of the kind of technologies you get engaged in. This particular chart, there are 4 colours, in fact there's 5 colours on the chart. But just to talk our way around this chart, because it is very important about how we create the linkages between science and research, fundamental technologies and business opportunity. Our organisation fundamentally has moved to what we would call a challenge-led type of organisation. If you look at the fundamental challenges that we all face, the kind of challenges that government itself plays a key role in, our objective is how can we use those challenges to pull technology and science through to create economic wealth. And we have 5 key challenge areas that we've identified as biggest commercialisation opportunities. They're pretty high level, pretty generic. There's energy, there's the whole built environment, there's food, there's transport, and there's healthcare. And each of those 5 challenge areas, in many respects, are completely technology agnostic, but they're trying to address a fundamental challenge, whether it be an environmental challenge, whether it be an aging population challenge, whether it be trying to address a traffic congestion type challenge, and use those challenges and build competitions and funds that will actually help business and pull science and technology through. So those 5 sort of blue technology or challenges at the top are where the bulk of our financial investment goes. The 4 red boxes on that chart represent probably our links back into the fundamental science base, our fundamental links back into the research councils, for example. And they are more about underpinning technologies and how underpinning technologies can link back into challenges. So our underpinning technology investments are around advanced materials, they're around information and communication technologies, they're around electronics, photonics and sensor systems, and they're around biosciences. And we invest in particular technology programs that are very strong collaborations between business and university in those fundamental technologies. And if you take just healthcare as an example, healthcare as a challenge, at the top right of that picture, may be using the technologies around materials, ICT, electronics, photonics, and biosciences. So they pull on those underpinning technologies. And very traditionally, the universities are more likely to engage with us in funding competitions around the red underpinning technologies. We've also identified 2 areas that we don't see quite in the description of a global challenge, but nor are they fundamental technologies, and they're around what we describe as competencies, high-value manufacturing and digital services. So that little framework there represents a framework of our investment of some £400 million per annum. In fact, the distribution of the way the funds work is we keep some of the funds back for investment in what we're now calling Catapult Centres, physical centres. We keep some of it back for responsive mode type of competitions. But if you look at that same picture presented in some sort of cartoon type of format, you actually see the distribution of our funds against those different priorities. And the first attempt to try and describe what the sub-level priorities are against each of those areas. So if you take energy, our sort of key priority areas in the energy challenge are actually around offshore renewable energy, they're around nuclear, and they're around fuel cells and distribution of energy. Our priorities around transport are around low-carbon vehicles, electric hybrid vehicles, they're around air transport, but around marine transport. If you look at healthcare, just as an example, our priorities there are around assisted living, they're around stratified medicine kind of initiatives, and they're around detection and identification of infectious agents. So when we start to move into this oceans of potential type of thinking, and the links to the kind of things you've been talking about, on this diagram I would say probably the two key areas where we're trying to pull science and technologies through are in energy and in transport. In energy, around the whole offshore renewable energy agenda, and in transport, in particular in marine, around marine transport technologies. They do play back, and the purpose of presenting the chart in this particular way is to try and show the linkages between those different challenges and different technology areas. Too often we find people in business and universities look at the type of funding competitions we have, and they look for very, very specific labels that relate to the science and research that they're involved in. What we're trying to do here is present a picture back where actually there are many different ways of engaging with the Technology Strategy Board. But as I say, offshore renewables and marine transport are probably the two big challenge areas that we engage in. In terms of materials and things, I mean, the whole subject matter that you've been talking about over the last few days, things like digital and the way digital helps to support the commercialization of science in that area is very, very important. The different type of tools that we have as an organization and people that are trying to work out the different funding mechanisms and how they can engage with the Technology Strategy Board, we offer a wide range of tools, particularly aimed at supporting business. We don't support academic research or universities per se. We support academic research in universities where business sees strength in supporting them. Not that we don't believe in the support of academic research and science, it's just that there are other funding bodies that do that. The reality is, with that sort of philosophy, there's still about 1/3 of our funding works its way through into the science and research base. And this chart here shows the various types of tools that we have and that we offer to business to try and help support the commercialization of ideas. Some of them are funding tools, tools like SMART, which is a single company-based investment tool. It's done in a number of different stages: proof of market, proof of concept, demonstrator type of funding, usually done on a shared public-private sector basis. Collaborative R&D is where we provide funding competitions against our thematic priorities. Knowledge transfer networks is getting more into the knowledge exchange agenda, where we're supporting building communities between science researchers and business individuals. We have some 55,000 people engaged through 15 or so knowledge transfer networks. Knowledge transfer partnerships, which actually this particular university, Plymouth University, is very strong on knowledge transfer partnerships, which is a way of engaging business and universities in a way that transfers knowledge from universities into small businesses to help them solve problems. Things like Catapult Centres, a new initiative. We've invested some 70 million, well, £200 million plus over a sort of 4-year period in a series of Catapult Centres, large physical centres with access to world-class people, world-class equipment that allows small businesses to take the kind of ideas developed in the science base and commercialise it and get closer to market and bring close to industrial scale to research and development. We have initiatives like Eurostars, which is working very closely to help small UK businesses work in the European environment. We have innovation and knowledge centres. Catapult Centres are very much business-led centres. Innovation and knowledge centres is a mechanism where we're working very closely with the UK research councils. There are about 6 or 7 innovation and knowledge centres, and I would say they are the closest to what I would see as the Fraunhofer type of concept in the UK. So what I'm trying to paint from a technology strategy board in the way we commercialise ideas is a series of priorities that we're focusing our investment in on, and a series of tools that we use to help business commercialise those ideas. As I say, the Catapult Centres is a new initiative. The vision is to build a network of world-leading centres. And to date, we have announced 7 different Catapult Centres. 3 of them, or 4 of them now, are operational or getting close to being operational. There's the high-value manufacturing catapult. There's the cell therapy catapult. There's the offshore renewable energy catapult, satellite applications catapult, connected digital economy, future cities, and transport systems. And I would argue, again, in the commercialisation of the science and research that you've been talking about this week, there are at least 4 of those catapults very relevant to the agenda that you're talking about. High-value manufacturing, when we look at particularly offshore marine and some of the things that are being doing, the development of commercialization research in the context of high-value manufacturing impacts the marine industry, the offshore renewables energy industry. Offshore renewable energy has been focused around how we in the UK can take advantage of 30 years of subsea engineering, world-class subsea engineering capability, and use that and bring that capability to bear in what we see as a very significant new market around offshore renewable energy. Satellite applications catapult is how we take advantage of the masses of data that can be gathered through satellites and distributed back to small businesses who are developing downstream business opportunities in terms of the analysis of that data, providing services back to business to allow them to work, whether it be through organisations like the Met Office or the Oceanographic Services or things like that. Connected digital economy is how we sort of, again, make money out of connecting the various aspects of the digital economy, whether it be machine-to-machine interfaces, whether it be about providing the linkages between the vast amounts of data that we're gathering and the businesses who can see ways of commercializing that data. So catapults is a very, very important part of our tool set and agenda. And indeed, if you look at the high-value manufacturing catapult centre, things like the Rotherham, the Nuclear Advanced Manufacturing Research Centre, the Centre for Process Innovation up at Sedgefield that's looking at plastic electronics, the National Composite Centre at Bristol, really sort of bringing to bear capability into the commercialisation area. Just a couple of examples. The National Composite Centre at Bristol is very much looking at how we can bring lightweighting of materials and manufacturing into the marine industries sector. The marine industries sector has developed a new technology roadmap that is defining, helping to shape where business places its investment. And this is just one example of where the marine industry sees its investment. Marine does form a key part of our transport agenda, and we're currently working with businesses right across the UK to develop, as I describe it, a technology roadmap. And if you're looking at routes to commercialization or exploitation of science and technology in this area, to see how it links in with that technology roadmap, I think is very important. Just here in this part of the country, in Plymouth, Princess Yachts is one of the world's leading providers of luxury yachts, working very closely with us in terms of the implementation of lightweighting technologies, plastic electronics types of capability, modern and advanced technologies in terms of communication systems. There is a European, a marine competition, the Martech competition, which is being jointly funded by the Technology Strategy Board. And indeed, Plymouth will be hosting one of its steering group meetings in November. We had a marine activities competition that was launched in January. 7 different projects worth about £6.5 million. Again, Plymouth, an advertorial for Plymouth, being one of the key areas of the country that has engaged in that marine industries competition. vessel efficiency is a competition that we've just very recently announced we'll be launching in January 2013, about £8 million co-funded between the Ministry of Defence, the Technology Strategy Board and Scottish Enterprise. So I'm painting a picture in a funding sense of how an organisation like ours is bringing together funding from various different organisations. So I'm not an oceanographic science or research expert. I understand a lot of the sort of conceptual ideas that are being put forward. Our organisation is looking at how we can create the tools and the capability for SMEs and companies to actually take those ideas and technologies and move them forward. Just yesterday, our Secretary of State, Vince Cable, launched a new government industrial strategy. And in that industrial strategy, the kind of support that the Technology Strategy Board is giving to the commercialisation agenda was a key part of what he talked about. So from my perspective, a very different perspective, I guess, to the things you have been talking about in the last 3-4 days. Our organisation, the Technology Strategy Board, is very much an organisation working with business, looking at how we can support and stimulate innovation and create economic benefit out of it. So thanks very much for the opportunity to say a few things and to meet with you. Thank you.